me just go. What's going on? Who's that? Guess who? Peter. Got the drinks. What's up? What's going on? Give me just a second. Doing calculations. This is the boring part. Yeah. This is for 10 concentration. X 0.0 liters. So 100 microliters. Yeah. Guess. Yep. Microliters. Okay. Shane's doing a lot of dabs today. Oh, I have not watched anything from her. Get me out of the lab today. Dragon, feel connected to the part. There you go. I'm actually mixed-handed. And I thought I was left-handed, but I prefer fine motor movements with left hand and sort of gross or more strenuous activity in my right hand. But I write predominantly with my left hand. Next time I do that calculation, just double this. That'd be 200 microliters of 1 molar magnesium chloride. I'm doing an assay, metal ion, specifically a magnesium assay using lysates of yeast. It's a nice. What's going on? What's going on? Yes, they are indeed, Crystal. Yes, they are indeed. Just need to do 0. It's just buffer. I have to separate all this out so it looks nice, so I can see it in my calculations. This is the boring part that people show you in movies. Sit down and calculate everything. It's 50 millimoles and 100 millimoles. What's the original concentration? Oh yes, one molar. That's right. Hear me talk. Because that's what we do. That's what we do. It's doing dilution equations. Right-handed for absolutely everything, left-handed for hockey stick. That's interesting. So to beat people, you use your left hand. That's what a hockey stick is for, beating people. Okay, now I can just double the 50 millimolar and get the 100 one, so I'm going to do that calculation. That works. I'm going to do the actual fun part in a second, once I get done with the calculations. Actually, I need to be thawing out the lysate. That's so. That's so. That's good. That's good. Keep doing that. Keep doing that. It's healthy. Healthy release. What am I writing? What am I writing? It's not even. Is it 0.030? 30. Okay. Let's let's not screw up simple math here. Okay. And then double that to get the 100 molar concentration. Red and green flames. No. Well, I could actually. I forget the colors. I think what's iron gives off the green color. I think. Magnesium is blue. No, that's not right. That's not right. I've shown that to my son. Just using some stuff around the house. Doing crosswords. Yeah, this is a little different crossword puzzle than what you're used to, but it's dilution equation. So essentially, I have to make I'm making Kool-Aid and adding in magnesium chloride to it. It's a very, very alkaline Kool-Aid, and I need varying concentrations of the Kool-Aid. So I'm trying to see how much of the salt I need to add to my Kool-Aid. Instead of sugar in this case. Phosphorus, magnesium. Yeah, I have magnesium here. There's I wonder. I have no, that's a sulfate. That's not a phosphate. There's phosphate compounds here, but I'm not burning those because we need those. There's paranitrophenol phosphate over in the biochem lab, but that's actually for the experiment because one of the other things that I'm working on, actually me and my lab partner are working on, is redoing undergraduate biochem course, and what they're going to be doing is taking paranitrophenol phosphate and turning it into paranitrophenol, and so there's an enzyme called alkaline phosphatase that takes the phosphate off of that, so it goes from PNPP to just PNP, and they have to essentially, see if they can change the enzyme to make it more efficient, make it less efficient, just do all kind of stuff to it. But you have to know a little bit of molecular biology in order to know what to do to it, or what you can do to it, I should say. So I'm just running some validation tests with the tolerance of the enzyme that we're going to be using various degrees of magnesium chloride, changing the temperature, and then changing the buffer. The buffer we're using here is it's a Tris buffer. And I think it's around 7. I think it's 8. I think it's around 8 on pH scale. But I'm supposed to be getting in some AMP, which I think is aminophenol phosphate, aminomethyl phosphate, AMP buffer. I have a Google machine right here. I was just typing in. Oh, Sigma Aldrich. Oh, propanol, aminomethyl. I keep saying phenol. Aminomethyl propanol. That's what it means. Okay, AMP. So we got to order some of that, and then I'll run similar assay using that particular buffer, since it's around like a 9. I think it goes up to 9.5 in some cases, but it's definitely around 9 pH. So that'll be fun. But actually, I need to remind somebody to order that because I'm not sure if it did it the other day. All right, back to math. But that's what's going on. Working on a few things. Just got out of physical jail, so I'm glad to make it for the stream. Well, that's good. So why were you in jail? Don't mind me asking. Physical jail. Dot x equals 0.30. Yeah, it is. So this will be 300 microliters. Chloride. Something that should be 500 microliters, and it should be 1 milliliter. Chloride, 1 molar. Let me double check. Always double check. Instead of doing math in our head. That should be very simple. 10 milliliters. Inside was. Is it that much different? I wouldn't know. I sound way different. I sound more manly to myself because vocal cords are right here. My ears right there. Well, tympanic membrane's back in there. So my voice sounds a lot deeper than it really is. To me. That's to my nitrogen. What was I doing? Let me figure out what I was doing. What was I doing? Oh, I need to check my math on that. Make sure. Let's see. This is the concentration of 100. Be point. Okay. Why am I hesitating on that? This is 10. X equals. Maybe some chloride. Listen to. I'm just muttering to myself. Is that wonderful to listen to? Just trying to make sure, because I hate wasting reagents. I really hate wasting reagents. I can't tell you how much I despise the idea of wasting reagents. I was supposed to check some. Oh, yep. Yeah, okay. Guess I'm not going crazy. All right, so this one. So that's blank essentially. Okay. 50 microliters, 100 microliters, 100, 300, 500, and then 1 mil, and a 10 mil tube. Those Falcon tubes next to you? The 10 mils? The ones on the right already
yes.
open.
Do you have more?
Yeah, we have 2 more packs. I just want to make sure you
have them. I'm gonna need more than that.
You're gonna need more?
Yeah.
Yeah, let me give you the full pack. No problem. All right. Let's see. Okay, they didn't take all my pens. There we go. So 2, 3, 4, 5, 6. I just need gonna be able to run this assay today. Oh. All right, this is better. All right, let's see. I'm gonna do this. Let me read my protocol. I could do that. Read my protocol. So happy 420. What's going on, folks? Yeah, it's a happy 420. Oh, he wants me to vary the concentration of the substrate as well. Okay. He must have added that after. Which makes sense. Yeah, checking enzymatic activity, varying the substrate makes sense. Village hidden in the clouds. I think that's what a Raikage is. I think. Let me see. Yep. Okay. Yes. Yeah, that's Village hidden in the clouds. You have to be a Naruto fan to get that. Okay. Let me think. 5 millimolar. Okay. 10 millimolar. So what are you doing today besides stuff? I'm gonna attend a class later tonight and listen to other people present their cell signaling pathways. Well, I'm gonna be listening to that. Probably playing some online games with my son, and also finishing up. Finishing touches on a presentation I got to give tomorrow over Zoom. Nothing too much. I know what today is. Also, you can kind of read between the lines. Wish you could be as talented and lab as someone like TE. Bond, I wish. You see, you've been around for a while. I wish, man. It's funny actually. Since you made a TE reference, do you know that like a part of my research is based in ATP, like ATP synthase. That's actually like a big part of what me and her do in the lab. So it's just universe is fun that way. I've had to learn more about it now, and I still crack a smile because if you think about all the time this guy mentioned ATP synthase, and then now that I'm actually like it's a part of my education, I need to actually master sort of like my knowledge of that entire enzyme complex in order to get my degree. You compare that to this fascination with it. It's like if you were to put it on a scale, his knowledge about that enzyme, that much. He probably a little bit about it. He memorized some of the subunits, but he actually knows dick all about it. And I'd love to have a conversation with him, right? Like today, like to think, just to see how much he thinks he knows about it, right? Obviously, it's me like dick waving, but he made such a big deal out of the thing, and it's so funny. You don't know. Education is funny. You don't understand a topic until you understand how much you don't know about it. That's how education actually works. Like he's just pissing in the wind and or what do people say? Try to find a needle in a haystack. You know, I'm not sure those idioms actually fit, but whatever. Like you don't know dick. There you go. It's the best way. That's the easiest way for me to explain that. Like it makes you laugh. Like so you sit back and think about it. Complex structure. And what the fuck does that mean? Complex. Okay. Yeah, a lot of things have complex structure. What does that mean? This mouse has a complex structure. A rock has a complex structure. If you wanted to mention something specific and pretty complex, look up the kinetochore. Kinetochore is pretty interesting, pretty complex. What they do. But I think it was I think it was an old nursing book that he had that he saw that and was just enamored with it, and then just decided he wanted to memorize. I think the subunits to the um, there's a V null and there's a V1 part. There's like a top and bottom portions of it. It's split into two. One's V null and the other's V1. And I think he memorized. It might have been what the V1 portion of it. I don't remember, but he could name the subunits, and I'm like, all right, like what the fuck does that actually mean? Like, do you know what it does? Do you know how it works? And how is that significant to your whatever your skill is? Always shout me out, good dude. I was okay, yeah, man, yeah. I showed you stuff the other day. I didn't get a chance to see it because I was busy, but I think I watched a little bit of it. I still need to learn new things. Chosen field, yeah, yeah, and that's the it lets you know, hey, there's always something more to learn. But the fun thing about TE is that he thought he was coming over here teaching people. No, Chief. No, not even. Not even. Not even. I have one. Oh, that's the blank. Okay. Give me a second. Need to read over my concentrations. 0 to 100 millimoles in the top overview tab. One note: just make a 10 or 20 millimole Trish 9 pH buffer. But yeah, the one it's already made. It's already it's already at 10 millimole. Yeah, 10 millimoles already made. Then make a 1 molar or so stock of magnesium chloride, and that the stock solution is already made. I think I got 50. I'm gonna have to make more because I have 6 containers. 1, 2, 3, 4, 5, 6. Yeah, I'm gonna have to make more. 10 milliliter aliquots, Trish, and the magnesium chloride solutions. Then use 140 microliters of each of those and 10 microliters of the 4742 lysate and freeze it and incubate them at 10 minutes at room temperature to read the absorbance. Okay. Which one to use? Put that back in there for right now. All right, let's take a trip. Actually, do some science. Anybody to get access to the SC domain in order to get access to the Deacon? Or
I just use my work email.
oh, you use the work? Oh, okay.
For TA.
Oh, got you. Okay, because I was trying to do PC Lab and it wasn't working out at all. Okay. Yeah. Okay. I'm gonna have to just look into that. All right. So I You want a lab coat? You can buy your own, man. Just go buy one. Not too bad, $40, I think. Someone actually bought this one, believe it or not. Someone actually bought this. I need to get one. I'm gonna get a new one with my name embroidered on it. All right, let me think. Oh, calculator. Okay, so let's start small. I'm mixing magnesium chloride with a buffer called Tris, and buffer kind of helps create the environment, a stable environment for whatever experiments you want to do. And let's say you have in this case, an enzyme that operates ideally within a certain pH range. You don't want that range to change while you're adding other stuff to it. You want to roughly stay in that area. So you have that buffer there to do that. So you can add stuff to that buffer that you're going to test. So in this case, I'm testing magnesium's sort of interaction with the substances that are going to be in there. In this case, it's going to be like you could think of it like a yeast extract, and that's what I'm making. Combination of the buffer for the environment, stable environment, and the various amounts of magnesium. Oops. I just made a boo-boo. 450. I need to fix something. I should have had this laid out better. That's my fault. 450. Correcting my mistake now. Okay, where's the concentrate on this? Yeah, I see what I did wrong. Yeah. Just a second. So, 900 microliters. Yeah, I misread some of the labels I put on there. But if you know what you did wrong, it's easy to correct. I just need to put in the difference. So, I put only 10 microliters, or was it? I put 100 microliters in my 10 millimolar solution, but the container was actually the 100 millimolar, so it needed a whole mil worth of my reagent. So I'm just going to add the difference. Hopefully that made sense. If not, I will explain it again in just a second. That's This is why you make sure you carefully read what you are doing. Pay attention. I don't pay attention. That's how you got contamination. Where's it's like 20 at? Okay, that's great. There it is, 10, 20, and 30. Okay, I was confused. 5. Alright, so I turn it around. So let me go back to 50. I could have just relabeled them, but I'm not going to do all that. Not going to do all that. 50. Okay. So this is not the best pipette for such small quantities, but I don't feel like changing out pipettes just to do that, and it's honestly not that important. You get less accurate with the broader range of a device you use. Let's see, so 110, okay, yep. So 100 microliters for my 10 millimole solution. There. My 20 millimole solution, I need 200. There we go, like that in place. This is how you're supposed to do it, like this. One hand, like that, and then you put it back on with one hand. It takes a little bit of dexterity, but like I said, my fine motor movements are for my left hand, so my right sometimes the best thing to use. It's good to practice. 30, I need 300. Oops. Check that. 300. Right, and this is a magnesium chloride solution that I'm putting here because I'm making dilutions. So I'll explain in a second once I get done. All right. Oops. Reason I didn't change my tip because these are sterile and it's the same thing. So there's no need. All right, so put these back over here. Now they're all done. I just need to bring these to level. This stock solution here is magnesium chloride, but it's at a 1 molar concentration. I need several aliquots of it at a lower concentration. So what I did some math in order to determine how much out of this I need to change the concentration, because in here it's just water and magnesium chloride, but there's enough magnesium chloride in here so that the concentration is 1 molar. So that's 1,000 millimoles, but I need a millimole concentration varied all the way from 0 to 100. So I have to do a little bit of math to determine that, which math is very easy. It's just tedious sometimes, depending on how many reagents you have in there. Anyway, the next step is using this here, which is a tris buffer. Again, I explained what a buffer is. I forget what tris stands for, but it's you can look it up. That's what it is, and it is an alkaline buffer. You see it says pH 9. If you can see that, yeah, pH 9 right there, the date and who made it. So I might be. I actually could use that pipette, but I'm just gonna decant. No, I'm just going to decant it. It's less than 10 milliliters. Okay. Let's see if anybody have any questions. Drake, have you ever been a teacher? No, I've never been a teacher. No. Have I taught people things? Yes, but I've never had a formal contract. I've been a tutor before. I've actually been a paid tutor. forgot. Oh, this was made recently. I need to test this. My fear was that this was made a while ago, and even if it's in this container, which it'll keep it protected from like auto lysis, but it'll go bad eventually. Like buffers don't, they have a pretty good shelf life depending on what they are, but they can go bad. And so occasionally you want to test it just to verify that it's still pH 9, because it's useless if it's not. If it goes back to like near neutral, it defeats the purpose of me using it. But it was made like in less than a month ago, so it's fine. All right, so what we need to do is bring these up to 10 milliliters, because that's what we calculated here. That's what you see. Yeah, you see it here. You can see 0.010. You can see it there. All the 0.010. That's to account for this here, the new solution that it's going to be in, new container, new amount. So that's what we're doing. Okay. So check VC ounce kit. Might help if I take the top off. So I can see the numbers. A little bit over, but too much of a difference. It's 30. Rotate it. Step. That. There we go. All right. Oh, license. Give me a second. Let me think about something. 200, 20. That. Let me check my protocol. Okay, I know what I'm gonna do. What's the name of the protocol? Absorbance. It's definitely not on. Oh, duh. Okay. Plate. had to send a text message. Here. Here. Okay. Oh, one more. Almost forgot. 0. Which not gonna have anything other than this wrist. So there. So I'm not gonna do that anymore. Make sure this is properly labeled. 0 millimole. Okay. Think about where I'm going to put this. So I should run it in triplicate. Let's lyse. Well, I need 10. Well, yeah, 10 microliters of lysate. And there's 7. Yeah, there's 7 total. 7 rows. 7. So if I go from 0 to 100 millimoles in concentration, my top row will be my blanks. I should have. I think I have plenty in there. How much lysate does he have left? Because I don't want to use all of his lysate. So if I just do 1, which I shouldn't, it's just 70 microliters. But then it'll be 210 microliters if I run them in triplicate, which I should do. Validation and average them. And then, well, I should run them in triplicate and then take the average of the top roll, which will be my negative control. And then, average that, subtract that, and so that'll eliminate the noise out of the replicates. And then average the replicates after I've had the noise subtracted, and then I could get the absorbance from them and determine based on the concentration. Yeah, so I could take the absorbance based on the various concentrations. That's what I'm looking for. I'm talking out loud. So I need to make sure that I have enough. He has 2 wild types here, 4742s, and there is a 0.5 ml in there, so I'll definitely have enough to run. How much is in this other one? Oh, there's plenty in there. Let me, because he did a validation check on 4742 on both wild types. I'm talking out loud. Katya, did he show you the validations that he did recently for 4742, the wild type with different lysates? Okay.
Yeah.
Okay. I was just wondering because he had explained to me that he said that he'd taken they're the same strain, but he had isolated them at different times. So I want to use the most recent one.
Yeah.
That's okay. That's
You
okay.
can text him.
Yeah, I don't want to bother him because it's really not that big of a deal. Because I'm just going to use the most recent one, and I'll isolate more later. So okay, you heading over to do the lecture?
No, I'm gonna get some coffee.
No coffee.
I'll be back.
All right.
You want any?
No, thank you. I appreciate it. I'll take some bourbon. I'm gonna isolate some more 4742 later. I'll do that. Give me a second. I got something. I have to get some water. Okay. So here's what we can do. So are people actually following along with what I'm? Hopefully it is helpful. Because this lysate here contains the alkaline phosphatase enzyme that is going to be interacting with. Hold on. Okay, so what I just thought about something. If I need my substrate, I don't have the substrate. There's no purpose. I can't test anything if I don't have the substrate for the enzyme to act upon, right? Because I have the buffer is the environment. What I'm testing is the enzyme's ability to do its job upon the substrate with varying concentrations of magnesium. And I probably should have explained this earlier. The reason why I'm using magnesium is because magnesium is something called a cofactor. Now, if you think about like your blood cells, you know, you've heard of hemoglobin. Well, your hemoglobin is actually a protein complex. Like it's multiple proteins, but then it has a particular heme group in there that binds the cofactor, which in this case is in that case it's iron. In this case, the cofactor is magnesium. So in order for it to do its job, it needs that cofactor, this metal ion, in order to operate. So the efficiency of how an enzyme can do its job will be based upon the availability of that cofactor, obviously. So that's sort of what we're testing. But in order for me to test that, I need the substrate. Now, I keep saying substrate. If you have an enzyme, it's a protein that does things. It needs to act upon something. That thing that it acts upon is a substrate, and that's the language that we use for chemistry. Does that make sense? So what I did not get from my PI is how much of the substrate to use, and I think it's 150 microliters, and that'll bring the total volume up for each well up to 300 microliters. And I think that'll work. And I'll let it incubate for about 10 minutes. So I need to double check. I don't see it in here. So I sent a message to my PI asking him, but that means I need a substrate, and I don't have substrate here, and I don't have paranitrophenol phosphate on hand. Okay, there we go. All right, so that's taken care of. So yeah, let me continue with this experiment. But I need to know how much of the substrate to use. I think it shouldn't hurt anything if I use 150 microliters of the paranitrophenol phosphate, because the product that I should get is paranitrophenol without the phosphate, because the alkaline phosphatase takes away the phosphate group. So it goes from PNPP to PNP. That's an easy way for me to remember, at least. Do I have any paraffin? All right, so I'm gonna take a walk. Oops. These gloves off. Because if not, I gotta fix it. Miss Parker got you. What you mean by that? How you doing that one thing? Beautiful outside today. Okay. Where did he put the paranitrophenol on? Is it room temperature? Okay. I should have probably also brought the other reagent. We'll cut out. This is my BCA protein assay. I use this to determine the protein concentration. If you like that crude lysate, I have no idea what the concentration of the protein is, but I can use this to determine what it is. What was I looking for? Tris. Nope. What is this? Oh, it's BCA solution. I need that there. There you go. All right. It's 10 times solution. This is the product. I don't need the product. I need the substrate. 1 millimolar PNPP. Aha. We found some. We got some. All right. Now, see there, kind of sideways, but looking at flex. I'm not flexing at all. I'm just trying to think. Is she still stream sniping me? Is she actually still? Yeah, y'all sitting there watching this? I said I was going to do. Did I say I was going to do triplicate? Did I? Are we doing triplicate? I just take this. I'm just going to take this whole thing. I'm not. Why even guess? I'm just going to take the whole thing. Why not even sitting here? I mean, who's going to yell at me? Who took the paranitrophenol phosphate? Me. I took it. I took it all. Let's make some more. One of the only other black science nerds, I just saw him go in there. I should probably remember his name. God damn it. I feel kind of bad. Yeah, he's usually in here. He's an environmental chemist. He and I were talking, obviously, nerd stuff. But he's doing something with metabolites that appear after oil spills, like the chemicals that they use to clean up the oil spills. There's some type of metabolite that occurs. And I think he's studying that, if I remember correctly. Yeah, that's more environmental, organic stuff. Am I still getting stream sniped? Are you stealing my content? Don't steal my content. Be original. So, it's gonna cut out in a second. Back to freaking Canada. Okay. What do you think? You can use it at 1 and dilute it. I already have 1 millimolar. Yeah, I already got that one. transportation man can be a scientist. Oh. Okay. It's, I'm glad that okay. Okay, so I need to dilute it 1 to 10 into the stock solution. Or no. Oh no, into mine. Okay, I see. Give me a second. Okay, so I made solutions of 10 milliliters. So I just put 1 milliliter of to put 1 milliliter of PNPP in the ones that I made. Fine. Okay, I know what I'll do. So I'm going to take out 1 mil from what I've already made, and then I'm going to yeah, 1 mil of the PNPP to bring it back up to 10 mils in order to keep the same volume, same concentration. Lots of magnesium chloride and tris. So I can decant 1 mil from each and add in 1 milliliter of PN. Correct. Okay. I think that's the best way to do it, because if I just throw in another mil, then it's going to change the volume. Then it's not going to be the same concentration, because now I've increased the volume while the actual content of magnesium chloride has remained the same. So we make sure that my logic works there. I understand how concentrations work before I do that. That should work. I mean, I don't see why not, but I'm double checking. 10 millimole? No, oh, that's just written up. Alright, fuck. Wait, 10 millimole stock. Who's he asking? So I grab the 1 molar of the fridge. Orbitals and shit like that. I've not needed to talk about that at all, and only organic chemists that broken down need to be concerned with that. But a small bottle Okay, okay. I'll grab that and use it if it doesn't already after removing Okay, I'm trying to make sure I understand this correctly because I didn't, and I'm glad that he mentioned that because the PNPP that I just read already has chloride in it, so it kind of defeats the purpose of me making these different concentrates with the addition of PNPP. Communicating. Does DNA dissolve in water? Yes, it does dissolve in water. Yes, like 10 million more. I thought it was in a clear. Or no, that must be the stock solution he's talking about. I'm just gonna do it. Go for it. Fuck it, I'm gonna do it live. If I screw up, I screw up. All right. Okay. I gotta find a PNPP. No, I'm just going back to Balkan Lab. Okay. Am I still getting stream sniped? What are they working on? Get my steps in today. All right. So when I'm walking, I need to think about what I'm doing. Right. So I'm writing up the lab notes for this. I need to be able to. Lysate contains enzyme, alkaline phosphatase, hexapon, para-nitrophenol phosphate. So it's clear in color. The substrate ends up creating the product, which is para-nitrophenol, which is yellow. Phosphate buffer. Phosphate buffer. This is the product, though. This isn't the substrate. Yeah, this is the 10 millimolar concentration, but let me say something. Where's the large glove? I need them. What the hell else use large gloves? Come on. Oh, right here in front of my fucking face. Okay. Yes. Astronomy is interesting stuff. Cosmology. Actually, my little brother's is very interested in astronomy. Encouraged him to pursue that. I knew it. That's product. Yeah, that's product. I need that. Aha, I found it. Yep. Okay. Here we go. Okay, this is what he was talking about. I have to say it. Couldn't find it. I don't have it. So it's paranitrophenol phosphate. So there we go. This is at a 10 times concentration. You might not be able to see it. 10x. I only need 1 millimolar. So yeah, so I can just, after I decant 1 millimolar, 1 milliliter out of my aliquots, I can add in this substrate in at 1 milliliter each, and then go ahead and mix those up and put those into my 96 well plate in triplicate, and then add in 140 microliters of those aliquots in triplicate to the 96 well plate, and 10 microliters of the lysate to each of the replicates. Let it incubate for 10 minutes, and then run an absorbance assay on it at 400 nanometers. Okay. All right. I could have saved myself a lot of time if I would have sat and thought about this a little bit further before delving into it. I just kick myself in the ass with it. All right. So let's think about this for a second. Okay, I know what I'm doing. All right. So before we proceed, clean the lab station. Okay. Oops. All right. So let's change this to 1 mil. Here. Okay. Let's do that. All right. Oops. My glasses off. What the hell that happened? Okay. Just super clumsy. Alright. Next one. Should it to the side so I don't accidentally pick up the same one. You always got to watch where your tip is. Make sure your tip's not touching what's not supposed to. Always be cognizant of your tip, gentlemen. Always. Tip's very important. And ladies. Okay. Why I didn't think about the substrate earlier. What kind of biochemist doesn't think about that, right? Enzyme activity without the substrate. Okay. I'm changing my tip every time because now it's different concentrations of magnesium chloride. If I would have started from the lowest concentration and went to the highest, I wouldn't have had to worry about anything because I'm not gonna contaminate a lower or higher concentration of something with a lower concentration of it. That doesn't really happen. I'll just decant this. All right, cool. So it looks like my explanation was right anyway, because it's like I can't make a concentration and then increase the volume, right? And that because that changes the concentration. So yeah, there's a lot of overthinking that happens. Like it's simple shit when you sit back and think about it. It's really simple, but it's most of science. It's just, hey, yeah, I know this is the case. Yeah, I'm not. Am I being dumb? No, I'm not being dumb. Or maybe I am being dumb. Or maybe I'm fooling myself into thinking that I'm right. Let me ask somebody. Okay, now I feel dumb because I was right in the first. There's so much of that. So much. It evidently just happens at every level. Trying to reassure yourself that you're not going crazy. All right, this is my substrate. Okay. So what do we say? We're going to add 1 ml of the substrate into each of our fucking things. Our experiment. There we go. Let's see. Oh, I wonder who was doing that. This is why we clean off our surfaces, folks. I should have been more diligent when I first started. My top's back to where they were. Okay. All right, so now I need to